A part deals with what? E is 0. Electric field is 0 inside a conductor. Suppose you have a sphere, solid sphere or hollow sphere in material. If you place charge, charge resides on the surface because positive will repel and charge will try to stay as far away as possible. So electric field lines start from positive, they will reach up to infinity. Exactly below this, plot E as a function of R. Notes बंद कर दो. Yes. What about inside? Y 0. E represents what? Number of lines per unit area. There is no field line inside. Field lines are only outside. That is why inside E in is 0. Outside, at any point, if you want to see electric field at any point, which is a distance R. Yes. E in is 0 as number of lines inside is 0. At this point, yes. How you find electric field at this point? E outside. E outside is number of lines per unit area. How many lines? If charge present is Q, out of 1 coulomb charge, how many lines? 1 by epsilon naught. 2 coulomb charge, 2 by epsilon naught. Q coulomb charge, it is Q by epsilon naught. Area, 4 pi r square. So it is Q by 4 pi epsilon naught r square. E outside is inversely proportional to r square. So outside, as r increases, E decreases. E outside is inversely proportional to r square. 1 minute to complete. We'll first take up C part, not B. We will take up B part after taking up C part. So C part is how V varies, how potential varies for the same configuration. That means exactly below this, you have to find out potential. You have to draw how V varies with R. 1 minute to try. Outside, we have proved earlier, V is equal to integration of EdR. That's area under this graph, this area. If you want to find out potential at this point, area under this graph, integration. What was the answer? Q by 4 pi epsilon naught R. This we have covered in previous questions. So V is inversely proportional to R outside. outside V is inversely proportional to R. Inside, yes. Yes, answer please. Inside, E is equal to minus dV by dr. E in is what? 0. Minus dV by dr. 0 means dV by dr 0 means what? Differentiation of something is constant, something is 0 means V is what? A constant. Now potential value should remain same. What is the value on the surface? Say 100 volt. Then at this point also it is 100, at this point also 100, 100, 100. Potential at all points remains a constant. So inside voltage is constant. So V in is constant. And the value is same as that of potential on surface. 1 minute to complete. Same question, B part. Yes, what do you want to prove? E is normal to the surface. Electric field is normal to surface. Surface on which charge resides. So, there is an object, say sphere. On this sphere, you place some charge. We want to prove electric field E is normal to the surface. This is what we want to prove. Field lines leave the surface normally. This is what we want to prove. Let us assume E is not normal to the surface. E is at a certain angle. Say theta. It will have two components. If it is inclined at angle, it will have two components. E tangential and this is E normal. Tangential component is what? E tangential by E. Yes. In this triangle, Et by E is equal to what? Cos theta. So Et is equal to what? E cos theta and En is equal to what? E sin theta. Yes, anyone. What is the significance of E? Electric field means force per unit charge. That means there will be some tangential force acting on the charge. If any tangential force acts on the charge will move. That means if there is a force acting, if there is a charge, if you apply a tangential force, it will shift to a new position. So if charge is in motion, then it is not charge at rest, then it is not electrostatic. You will, this chapter 1 deals with what? Charges at rest. If charge is at rest, that means it is in equilibrium. If it is in equilibrium, that means net force acting, tangential force acting is 0. That means what? Et is what? 0. That means E cos theta is what? 0. E is not 0. That means cos theta is 0. That means theta is equal to what? 90. Yes, theta is equal to 90 degree. That means this value, this diagram, now you need to modify. This diagram is, if theta is 0, then E is what? Theta equal to 90. So electric field is what? Normal to surface. 2 minutes with you to write. Shielding. To shield means what? To protect. So all instruments are subjected to electromagnetic noise or electromagnetic disturbance. Suppose there is a mobile phone and there is a source of electric field or electromagnetic radiations are there. Suppose it will disturb, it will get connected with this device. So if your mobile is nearby a TV or any other electronic device, signal in one disturbs the signal in other. This is termed as noise, electromagnetic noise. Any device, maybe cathode ray tube in the lab, any instrument in the lab you want to protect, you want to shield. Then you place this device inside a metallic shell. This is metallic shell. Enclosure. If you place this device, any device inside, if there is any noise, electric field line will hit the surface. What is E inside conductor? 0. So this line will approach this and will leave at some other point. But line passing through inside will be 0. Similarly here also, if this line reaches to this point, suppose if point reaching to be taken as negative, then it will leave from this point positive. This is negative, this is positive. What is the overall charge on this enclosure? 0. E inside is 0. This is how you can protect your device. This is termed as shielding. This is one example. This is example number 1. Example number 2, which we have discussed number of times, is if you are in a lift, this is ground. There is a building, tall building. There are stories above the ground. There are stories below. These are iron rods, wall, floor, wall, roof, all are iron rods. You have a mobile tower at this point. This lift provides, this enclosure provides what? Shielding. So if you are having a mobile phone inside the lift, then radiation from tower are bypassed and mobile signal is poor. Why? Because electromagnetic radiations from tower are bypassed because of this enclosure. 3 minutes with you to write.